The intention of this video is to show you how to use Microsoft Excel, which is the spreadsheet app that is part of the Office 365 suite. So I'm starting off with a sample from all of the U.S. presidents' heights in centimeters. This is just the first 11 of them. That's why it's a sample. And that's the President George Washington, our first president's height, in 188, that's in centimeters, all the way through whatever the 11th president's height was, which is 173. In order to find x bar, which is the mean, we have to add all these values up. So up in the right-hand corner is the auto sum command, and it's very good at guessing what you want to add up, which is all the numbers above it. In order to find out how many values are in the data set, even though it's easy enough for us to count them by hand, we're going to use the count command. So I double click on that and also grab the array, and it will count up how many numbers are in the array, which is 11. Remember, to find the mean, you divide the sum of x by n. So I'm going to click on equals here and literally have Excel find it from the formula by dividing this sum by this n value. And that cell has already been rounded to the closest tenth, but it used to have a lot more decimals when I first calculated it. So you would use the decimal decrease tool up here in the middle and the top to decrease it to tenths place. The standard deviation is a formula that involves the square root function. So I'll start with equals and type SQ. You'll see it's the square root formula. And in order to find the square root with the first formula we saw today, we took the sum of x minus x bar and divided by n minus 1 and then square rooted it. So we're not ready for this yet. We have to be able to fill out the rest of this chart. We'll come back to this formula. Let's just delete that. We have to find x minus x bar, which is the difference between each of these values in column E minus the mean that we just found of 176.9. So I'm going to just unhighlight these for the time being, but our goal is to find this yellow box, which is the sum of all those values. First of all, we're going to start with the first one, which is how much taller than the average U.S. president out of these 11 George Washington was. So I'll select on his height and subtract 176.9. And as I get close to that, after selecting that cell, my white cross turns to a black solid cross, and I can hold my mouse down and drag all those values down to find all the differences. And the formula then asks me to take those values and square them. So in cell G3, I'll click on F3 and raise it to the second power, i.e. square it. So that's the square of 11.1, and I can drag those values down similarly. So when I click on the cell, I'll click on the auto sum command, and it will wisely pick all those values above it to sum up. So that's the sum that's going to be used in the numerator of the fractional radicand under the square root sign. The formula, again, for the standard deviation is equal to the square root, so I start off with the square root function, of this sum of the squares, all divided by n minus 1. So I use the division key and open a parenthesis, and n is right here, and I'm going to subtract 1. And you'll notice that when I push enter, it's giving me 8.9. That's just because I accidentally put a little negative sign in front of square root. Oops, now I put an array accidentally. So there's the proper formula, and it's giving us that 8.9. When I first did this, there were more decimals here involved. You needed to use the decimal decrease command to get it down to the closest tenth. Notice that we can also find the mean by using the average command, like we saw last class period in section 6a. So if I use the equal, there's no such thing as a mean command, but we start typing AVE from average, and we'll find the average of all the values from the array, and it finds the mean right off the bat. Okay, it's supposed to be E3 through E13. I didn't drag down to that last value. So including all 11 of those values, it's the average of the values in cell E3 through E13. And you can see that it's got more decimal accuracy here. I'll just crank up that font a little bit and open up this width, and you'll see it's got a lot more decimals. So you want to push this button to decrease the decimals, and you'll see it's the same mean that we got before. The standard deviation of a sample is a function that starts off with S, T, D, EV, And the standard deviation for a sample is the one that has a .s at the end. And I just want to grab the array, and it will automatically find the sample standard deviation, which again is 8.9 to the closest tenth, and we would see that after decreasing the decimal. I'll just crank that up to 16 font. So now we can find the minimum, quartile 1, median, quartile 3, and max. And the first time I'm going to do it is including the median. So the min is going to be the same. You just use the min command. I'll click equals here, start typing min, double click, and it will find the minimum of all of those values, 11 heights, which is 163. And I'll jump to the fifth number in the 5-number summary, which is the maximum. So I'm going to use the max command and double click on max and grab the same array, and we'll find the maximum value for Thomas Jefferson's height of 189. The median, you use the median command, which is MED. It starts off with, double click on it for median, also grab the array, and it will find that median. If I grab all the data and right click to copy it, and then come over here to cell I3 and paste it, I can sort that list in ascending order. So now I'm going to highlight the minimum, which is 163, and the 189. Remember to find the median. You divide n by 2 and round up. So 11 by 2 divided by 2 is 5.5, round up is 6. So if we count into the 6th data value, this being the first, there's a second, third, fourth, fifth, and 6th. I'm going to highlight that, and what I'd like to do is just grab the first 5 values and put them in a bold box, and the last 5 values and put them in a bold box. So you can see how the median is not included here. So if I looked at the first 5, the third value would be quartile 1, and the third value in the last 5 would be quartile 3 if we excluded the median. And so here I'm going to use the quartile command with excluding to verify those values of 170 and 185. So I'll push the equals button, and for quartile it starts off with QUA. You'll see it's quartile exclude and include. We're going to start with exclude, and we grab the array, and we have to put a comma with 1 when we want the first quartile. And this is excluding the mean. I should change my type here to put EXCL. This is when we exclude the median. And same thing here. I'm going to change that to excluded. Because these two values right here and here, which actually instead of putting in yellow, I think I'll put them in green. Those are these values right here that are in green. And they're the middle of the first half and the second half, excluding the median. So here to find quartile 3, I start off with equals and QUA using quartile exclude command, grab the array, and put a comma for 3 because we want to find the third quartile. So you'll see how that 170 and that 185 are lining up with what the computer found. I'm going to grab this text and move it over. So I'm going to cut it and paste it here, and cut this value right here and paste it here as well. And now in order to find what the median would be if we included the median, I'll copy this and paste it over here, but get rid of all that formatting of the box so that there's no borders at all. And this time I'm going to grab the first 6 values, including the median, create a big box around those. Then I'm going to start at 173, including the median again, and create a big box around those last 6. So 173, I basically now need to find the average of these 2 values, because those are the third and fourth values, which are the middle of the first 6. And I need to find the average of these 2 values, which are the third and fourth, in the last 6, both including the median this time of 173 in the first and the second half. So we'll find that this median, including the median, will be the average of 170 and 171, which is 170.5. And quartile 3 will be the average of these 2 middle values of 183 and 185, which should be 184. So let's verify it with using the quartile include command. So I'm going to use the second option here. Again, select the entire array, put a comma with 1 to find the first quartile, and sure enough, that's the average of those 2 values of 170 and 171.5, which if I increase the decimal accuracy we'll see it's 170.5. Similarly, I'm going to use the quartile include command for the third quartile by using the quartile include command, the array, and now a comma with 3 to find quartile 3. And with including the median, we see that it is the value of the average of 183 and 185, which is 184. So these would be quartiles using the averages of the middle two values, and the first 6 and the last 6, both including the median. If I wanted a box and whiskers, the only problem with Excel is it does it in a vertical format. So if I grab the data and I go to insert and I click recommended charts, you have to click all charts to drag down to the box and whiskers, and I'll say OK, and it's going to plop it right here, and you'd have to hover over those values to see what they are equal to. When I get really close to that middle value, it should pop up what those values and how they refer to the data set. So you're seeing it saying 170 for quartile 1, and the median is 173, and up here is 185. So it's using what the box and whiskers in Excel is programmed to use the method that the graphing calculator also uses, which is to exclude the median. It doesn't do a box plot for the quartiles using the including median, which is, I believe, the way our book does it. Okay, long video, but lots of stuff here. Have a good one.